Here's question 3. It's a triangle type question, and I've already drawn the diagram. It really helps if you can draw a nice big diagram and make the coordinates fairly accurate in your sketch. So it's an isosceles triangle, it says, and we've got to find the area of it. We've got to show it's isosceles. It's not obvious from the diagram which two sides are equal in this, so let's just find the length of all the sides. So starting with AB, I don't really use any equations to do this. I just use Pythagoras. So going from A to B, we're going across 6 and we're going up 7. So the distance AB is going to be 6 squared plus 7 squared, 36 plus 49. That'll be root 85. And then A to C, that's going to be, let's draw in the triangle. We're going across 8 here, down 2. So it's A to C is 8 squared plus 2 squared, which is root 68. So root 68 down here. Mark these in as we're going along. So root 85 over here. So those two sides are unequal. Let's hope the other one is equal to one of these two, or we must have made a mistake. Then B to C, we're going across 2, down 9. So B to C is the square root of 2 squared plus 9 squared, which is root 85, which is good news because it is the same as AB. So AB equals BC, so that means it's an isosceles triangle. We now need to find the area of it, and I think you could probably do this. Oh, let's just mark in this side. So this side was root 85 as well, and it's isosceles, so let's mark those as equal. I think in this question you could certainly use the cosine rule, find one of the angles, and then use a half AB sine C. But let's try doing it by splitting this up into two right angle triangles, or just finding the perpendicular height really. So if we do that, then let's do this perpendicular height here. Okay, so if we call this H, and if we just do H times half the base, which you already know is root 68, then that will be the area of the triangle. So we're going to need to find the midpoint here, the midpoint of the line AC. It's fairly straightforward. Halfway between -2 and 6 is going to be +2, and halfway between -1 and -3 is -2. So the midpoint is 2 minus 2, and so the distance B to M, which is H, so H, we're going across 2, so it's 2 squared, and we're going down 8 plus 8 squared, and so that is root 68. So H is root 68, so that's the same as A to C. And so what we've got to do now to find the area is do a half the base times the height, which is half of root 68 times by the height, which is also root 68, and so that's root 68 squared is just 68, and then we half it, that will be 34. So the area is 34. That's the answer to part 1. Let's do part 2 now. So part 2, The question says we've got to find the point D, or the x coordinate of the point D. Now D is a point on AB such that the line C to D is perpendicular to A to B. That's why I've drawn this red line on here, because the question is just saying when we draw a line from C to A to B, where would D be in order for it to be perpendicular? Okay, so we know the line C to D is perpendicular to A to B, and we've got to find out what D is. So let's do some gradients, because we know that the gradient of A to B, when we do the negative reciprocal of that, that will give us the gradient of C to D. So the gradient of A to B, the gradient A to B, well, we just go across, we go across 6 and up 7. So the gradient of A to B is 7 over 6. So the equation of AB, if we use it, we use y minus y1 equals mx minus x1. So I'm just putting in the coordinates for A here, but you could use the coordinates of B if you liked. That would be 7 over 6 x minus 2. So we have y plus 1 equals 7 over 6 x plus 2. Let's get rid of the fraction. Let's multiply everything by 6. So we get 6y plus 6 equals 7x plus 2. So that means we have 7x plus 14 here. And that will give us, just getting everything simplified a bit more, we'll get 7x minus 6y equals minus 8. Okay, so we're going to use that in a minute. So that's the equation of AB. We now need to find the equation of C to D. So the equation of C to D, let's do that down here. So the gradient, let's do this in red. So the gradient of C to D is going to be the negative reciprocal of the gradient of A to B, which is, so we're going to get minus 6 over 7 for our gradient as it's perpendicular to AB. And so the equation of CD, again, use y minus y1 equals mx minus x1, and I'll use the point at C because I don't know what D is. So y minus minus 3 equals minus 6 over 7 x minus 6. So that's y plus 3 equals minus 6 over 7 x minus 6. Multiply everything by 7 gives 7 y plus 21 equals, just multiply, well, I'll leave it as it is for now. So that's this, and then we can simplify this, minus 6x plus 36. And if we get it into the form like this one up here, to make it easier to solve, we will get 6x plus 7y equals 15. So now we have our two simultaneous equations in boxes there, and we need to solve those two. Now it's fine to use your calculator now. So I'll show you how to do it. I'm sure at GCSE you would have had plenty of practice at maybe multiplying the top one by 7 and then multiplying the bottom one by 6, adding them and then solving it like that. That's fine to do, but just in case you don't know how to do it on your calculator, I'll show you on this one. Okay, so if you go to menu and then down to equation solver, it's the same for quadratics. You can also solve quadratics using this too, but you would go to polynomial solver for that. So if we just type in the top one, we've got 7x minus 6y equals minus 8, and then you've got 6x plus 7y equals 15, and then you just press equals, and that's the x value. We only care about the x value in this question because it doesn't ask for the coordinate, it doesn't ask for what y equals, so we can just write down that the final answer is x. So at point D, x equals 2/5, which is the answer to the question. Incidentally, if you did want y, you could just press equals again, and that would tell you what the y value was. So that's the answer. Just in case you're not sure about using your calculator to do that, it really is fine. Here is a question from a couple of years ago on the new linear specification, and it says here, in order to solve these two simultaneous equations, in the mark scheme it says you're allowed to use any methods including use of a calculator. Okay, so it is fine to solve quadratics and linear simultaneous equations by using your calculator the way we just did.